Hello students, I'm here with another video from the chapter of class 10th NCERT book, that is Carbon and its Compounds. Before starting today's video, I would like to tell you all that till now what all things we have discussed in this chapter. So we have discussed about the carbon, where is it present. So we saw that in each and every living creature, or whether it is a non-living creature, some of the body parts or some of the part is still made up of carbon. And we have also seen that carbon is present in human body also. So if it is such a major constituent of each and every living organism as well as non-living organisms, so we need to study about its presence, where it is present, I mean in the nature. So in the nature we could see that this carbon and its compounds would be is present in many, it is present in many types. Okay, so it is present in various forms. And if we talk about the carbon which is present in the surrounding, is in the form of fossils, is in the form of fossil fuel, is in the form of combined state of the carbonates. Okay, then we can see inside the sea also it's present in the form of rocks, it is present in the form of calcium carbonate in the shells of the animals, which is present inside the earth, inside the oceans or the sea. Okay, and we can also see that our human body is also made up of certain percentage of human body is made up of the carbon and its compounds. Now, if we talk about the various compounds which are made because of the carbon, it could be of three types, and why these carbons are very much used to for making such types of compounds. Now, what is so special about this carbon? So this carbon has certain versatility, that this is so versatile. Why is it so versatile? This is so versatile just because of certain characteristics like the tetravalency. Tetravalency means it has valency maximum of 4. It could not be just below 4 or above 4. Okay, so it is the maximum valency which an element could have. Similarly, it has a power of catenation. Okay, so we have already discussed about these versatile carbon's property, that why is it so versatile. That is, the second property is catenation, which means that it forms a long chain. And the third property is that it is forming the covalent compounds, which are really very stable. Now, what are these covalent compounds? Covalent compounds are just opposite to the ionic compounds. Okay, so this ionic compounds, when we can see this ionic compounds, these ionic compounds are those which are always formed by the transference of electrons completely. Now, if we talk about the covalent compounds, now what are these? So these are the special types of the compounds which are formed just because of the sharing of electrons. They are not completely given, or they are not completely taken up. The electrons are not taken up, means it is not completely lost, nor completely it is going to be gained. Now, what happens in this covalent compounds, in this covalency, or the covalent compounds has a tendency that these have the property of sharing the electrons. Fine. Now, what kind of sharing could be done? Now, sharing could be of three types. First is the single bonding, if means one pair of electrons could be shared, two pairs of electrons could be shared, and three pairs of electrons could be shared. Now, if one single pair of electrons are being shared, then it is known as the single bond. Okay, and if two pairs of electrons are shared, it is said to be as double bonding. And if three pairs of electrons are being shared, it is said to be as the triple bonding. Okay, so we can see that the the ways by which it could make the compounds is because of these properties of carbon, that is its versatility, which proves that it is so much versatile. Fine, because it could make numerous compounds, it could make numerous of compounds. Fine. So why it is making numerous compounds, now you could understand very well, because it has these tetravalency, catenation power. Okay, now today I'm going to teach you that how these carbon is going to make certain compounds. I mean, bonding is very important in this chapter. So we must understand that what kind of bonding we are talking about. So we need to understand that what about means how is this bonding taking place, means how is the single bond formed, double bond and triple bond formed. So actually this is not covered in your syllabus, so I'll just tell you about the electron dot structure of various compounds in today's video. Okay, as I have discussed earlier also some of the compounds, but still there is there are many more compounds that could be formed because of these electron dot structure. So it's necessary to understand the electron dot structure of the carbon compound. So it's not only carbon, we'll first see that how is this electron dot structure which could be made. Okay, so I'll just draw the electron. The electron dot structure. So how is this electron dot structure made up of? Let's see this. So this electron dot structure is just the representation of the covalent bond. So what does it represent? It represents the structure of covalent bonds. Okay, now what are these covalent bonds? These covalent bonds are those which are formed because of the sharing of electrons. Okay, so this is how the electron dot structure would be supported, just because of the sharing of electrons is being done when any electron dot structure has to be formed. Now I'll just tell you about how is this electron dot structures to be made and how it is so easy, why it is so easy to make these electron dot structure. It is because that we can easily understand that how is the electron being donated and how it is being shared. I mean, how it is going to be shared. Now I must tell you that we'll start with the simple atoms. We are going to start with the simple atoms. Okay, I mean how is this electron dot structure going to be represented in the form of simple atoms. First, how the molecules are being formed of those simple atoms, such as we are going to firstly take the hydrogen atom. Okay, and how is this hydrogen molecule being formed? So we'll first take up this hydrogen molecule. So why I'm saying molecule? Because in atom we cannot say that an atom is going to form the bond, because when an atom is participating in the bond formation, it becomes a molecule. Why it becomes a molecule? Because when sharing is taking place, it is just for gaining the stability. It is the nature of any compound, it is the nature of any metals, or it is the nature of any chemical species that it has to gain stability. Okay, it is just the nature that every compound, every element wants to be stable in the nature. So for gaining stability, the atoms which are free and stable in its unstable in its state, they are sharing the electrons, because they cannot completely give or they cannot completely take the electrons. And how is this sharing being done? Let's begin with this. So we'll first take up this hydrogen molecule, how this is being formed. So this hydrogen molecule is going to be formed as we know that hydrogen has atomic number as 1. So how this is going to be configured? It is going to be configured as 1 in the K shell. So it has 1 electron in the K shell, and that is only the valence shell. Now there is one more way how to we represent this valence electrons in the form of the atoms. Okay, so how we are going to show this valence electron? We can show this valence electrons just by drawing this electron dot structure. Okay, so I'll just form the molecule. So we can write like this, H and H. We can use cross also. Okay, either we could use dot or cross. Okay, to form this electron dot structure. Okay, that is why it is said as electron dot, because electrons are represented in the form of dots. Fine. Now next, H has 1 electron here. Okay, next H also has 1 electron in its outermost shell. Okay, now these two are going to combine. Once they are combined, they are going to form one hydrogen molecule. So this is going to be shared with this. Okay, so because of the sharing of these one electron, because see, this K shell has to be filled with maximum 2 electrons in it. So it has one. So from somewhere, if it takes one more electron, it would be stable. So what does it do? It is going to take up the electrons from the next atom, which also consists of only one electron in it. So what happens? This is going to take up the electron from the next one, and that is why it has 2 electrons now. Now if one atom requires this hydrogen, it will take. The next atom, if it requires the 2 electrons, it is going to take up the shared pair of electrons. So this is how sharing is being done, and we could see that the single bond is formed between H and H atom. Fine. So this single bond is because of the formation, because of the presence of the sharing of 2 electrons. Why 2 electrons? See, as you could see here, it was having only one electron. It was having only one electron in the outermost shell. So now what has happened? So it has shared these pairs of electrons. Here you could see this pairing is being done. So this is being shared. So once this is being shared, how it has to be, why it has been shared? This has been shared because the electrons, the atoms needs to be stable. So gaining stability, it is going to share the electron pairs, and just one pair of electron is being shared. That is why it forms one single covalent bond, or it is simply said as single covalent bonding. So in between the hydrogen molecule, it has the single bond present in it. Now this line indicates the bonding. This is the force of attraction. Okay, so this line indicates bonding, and how many electrons are being shared here? So one pair of electron is being shared. So this shows that, this line itself shows that one pair of electron is being shared. Okay, now I move on to the next, one more molecule we'll form, and we'll see that how is the next molecule being formed. So I'll just take up the next example of the H2S. H2S means this is hydrogen. It is hydrogen sulfide. This is hydrogen sulfide. Now I must take this hydrogen sulfide. How this hydrogen sulfide is being drawn? Hydrogen sulfide is just drawn by the help of hydrogen and sulfur. So how is this hydrogen and sulfur helping? Hydrogen has the atomic number as 1, and sulfur has atomic number as how much? It is 8. Means it is going to form, here the configuration would be only 1 in the first shell. Fine. And the sulfur is going to have the 6 electrons in its outermost shell. So this has 6 electrons in its outermost shell. Why? Because its structure is, the atomic number is 16. Okay, so it becomes 2, 8 and 6. Now how many electrons does it require? It requires to complete its octet, as it is K, L and M shell. So this M shell can contain maximum of 8 electrons in it. So what about how it is going to complete its octet? Because it is having 6 electrons in it, last shell or the valence shell, it could gain 2 more electrons from somewhere. 6 plus 2, 8. Okay, so it will gain 1 electron from hydrogen and another electron also from hydrogen, and then both of these electrons could be constituted to form the octet of this sulfur, and this becomes a stable compound. So we'll just draw the outermost shell of this hydrogen, which is having 1 electron. This hydrogen also has 1 electron, and sulfur has how many? 6 electrons in the outermost shell. So we can represent 1, 2, 3, 4, 5 and 6 electrons are present in the sulfur atoms. Now I'm just going to draw the electron dot structure of this sulfur atom. How it is going to be formed? See, this is the this sulfur is having the large number of electrons, so this becomes a central atom. Okay, so this becomes a central atom which consists of how many? 6 electrons in its outermost shell. Okay, now if it is drawn in the form of cross, it could be 1, 2, 3 and 4. Now it requires 2 electrons from the hydrogen so that it could share its 2 pairs of two pairs of electrons, and then what happens? This is going to form this is going to form one more stable compound. Now how it is going to be sharing? So here it becomes 1, 2, 3, 4, 5 and 6 electrons are drawn. Okay, so this becomes sulfur and this becomes central atom. Now this we'll draw this hydrogen, and this hydrogen will be sharing one of its electron, and here also this will be shared by another hydrogen atom. Okay, as this also has this would share its electron. I'll show this with the help of dot. Here also this hydrogen is going to give its electron to this sulfur. So this unpaired electrons are also being paired, and with the help of this hydrogen, 2 hydrogen atoms. So the bonding, that is written as H2 and S. If you're not knowing the formula also, then you could understand very easily that sulfur requires 2 electrons to be shared, because of which it could form the stable compound. That is why there are 2 more hydrogens which are to be shared with the sulfur. So sulfur is going to share these 2. Now at the same time, only 1 pair of electron is being shared by this hydrogen. So what type of bonding will be formed? It would be with S, only one single bond is formed with this H and one single bond is formed with this H. So it becomes H, S and H. Okay, so this is hydrogen sulfide molecule. Okay, so this becomes hydrogen sulfide molecule. This is also written as H2S. Okay, so this is in the form of the H2S, and this is one of the stable compound formed by a single covalent bond. Okay, so this is an example of the molecule which is formed by a single covalent bonding. Okay, so this is about H2S. Now I move on to the next molecule which I am going to form again. See, we don't have to study about alkenes and alkynes. What about this alkenes and alkynes? I have told you earlier also that these alkenes and alkynes are the structures which are formed because of the double and the triple covalent bonds. We are not going to enter in those double or triple covalent bonds because we don't have to study about the unsaturated compounds. We will only have to study about the saturated compounds. So I have just given the brief idea about these unsaturated compounds also, but I'll not go in details. Fine. Now if you have any doubt, you could ask me regarding all these things in your online class. Fine. Now I'm going to begin with the next molecule, which is this methane molecule. Okay, CH4. So we'll draw this structure of CH4, that is methane. Okay, now how is this methane going to form? So there is one more way to represent. CH, how many? This has 4 carbons, so these lines could be drawn. 4 hydrogen will be satisfying these 4 atoms, 4 electrons of carbon. Okay, now if we need to draw the structure of this methane, so first you should write the electronic configuration of carbon, that is 6. It means 2, 4. Last shell has 4 electrons, valence electrons. I think now you would have learned it by heart. You would have learned this because number of times I am telling you that this carbon is having 4 electrons in its outermost shell. This is tetravalent, this is tetravalent. Okay, so tetravalent here only means that it contains 4 valence electrons. So again, this methane also will be formed because of this tetravalency of this carbon atom. So how is this tetravalency going to help? Let's find out. So this H is having 1 electron, as its atomic number is 1. So it has only K shell which has 1 electron in its outermost shell. Now I'm going to make one more structure. How this methane is going to be formed. So this methane is going to be formed in a very simple way. I will keep this central atom carbon, which has which has how many electrons in its outermost shell? It has 4 electrons in its outermost shell. 1, 2, 3 and 4 electrons in the outermost shell. So see, I am going to denote this with the dot structure, and we are going to satisfy this 4 electrons with the help of 4 hydrogen atom. Why hydrogen? See here, because it contains 1 and it needs only 1 electron. So total how many H atoms will be required for completing the octet of this carbon? Because it has 4, it needs 4 more electrons. So how many H it requires? It requires 4 H. That is why it's written here in the formula CH4. Fine. Now we'll adjust these 4 electrons with the H. 1, 2, 3 and 4. Okay. So this H is going to donate its electron here. This is going to donate its electron here, this is going to donate its electron here, and this is going to donate its electron here. So this is how the CH4 molecule will be formed. So how you are going to write this C with 4 pairs of electrons are being shared, but still each atom is sharing 1 pair of electron. That is why the single bonds I have drawn. So H, H, H and H. So this is how the methane molecule will be formed. Fine. So this methane molecule is formed because of the single covalent bond. Now please understand, here only I know that 4 pairs of electrons are being shared, but each hydrogen is sharing only 1 electron, and one electron of that carbon atom is being shared. So at total how many electrons? 2 electrons in each of the bonds. It means only one single pair of electron is being shared with the hydrogen and the carbon. So that is why the single bond is going to be formed. It's not going to be double bond or 4 times. 4 bonds would not be formed. 4 bonds are there, but it is the single bond. Okay, so how many single covalent bonds are there? 1, 2, 3 and 4. This is how you can count the single covalent bonds in the compound. So this counting also, it's very important. Fine. So we have drawn this methane molecule. You could draw many other compounds which contains more than 1 or 2 or 3 electrons. Okay, so let's find out one more compound with the carbon and hydrogen. I'll draw this. The next compound which we are going to discuss is this C2H6. Okay, so one more way to represent this C2 is first write down carbon and carbon, then as it shows catenation, and how many how many hydrogen has to be drawn? It has 1, 2, 3, 1, 2 and 3 places are empty. So it will be satisfy this H atoms. Okay, now I'll just draw this carbon here, and so this is going to be drawn like this, carbon and carbon. Okay, so this is how it will be formed. Now next what happens, this is going to have 1 electron, 1 electron, 1 electron and 1 electron here. Next 1 electron, 1, 2, 3 and 4. So this carbon and carbon are going to share 1 electron, because see two carbon atoms are there, so it has 2 and 4. Similarly 2 and 4. So how many electrons more are required? 4 more electrons are required. So if it gives 2 electrons to this carbon, now how much? 6 electrons are with the first one. Okay, now how many more? 4 electrons are more required. So how it is going to be? So here with H, 1, 2, 3, 2 and 3. So C2H6, H, 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 H and H. How many? 1, 2, 3, 4, 5, 6. Because these 6 hydrogens are going to give 6 electrons to these carbon atom, and it becomes, and 2 more electrons are here. See how many? Say this carbon can easily complete its octet, as you could see here. And I'll just draw this with the red chalk. So as you could see here, this one is having 1 H is shared here, 1 H is going to share its electron here, H is going to share its electron here, H is going to share its electron here, here and here. Okay, so this is how the sharing of electron is being done. Now you could see here this carbon can share 1, 2, 3, 4, 5, 6, 7 and 8. 8 pairs of electrons are there. It has completed it has 8 pairs, 8 electrons are there, means the octet is complete here of carbon. Similarly, this carbon also 1, 2, 3, 4, 5, 6, 7, 8. This shared pair will be counted with both of the carbons. Remember, shared pair of electrons would be counted in both the carbon atoms, and that is why it could complete its octet, means 8 electrons in the outermost shell. So here this carbon also has the 8 electrons 1, 2, 3, 4, 5, 6, 7, 8. Okay, 3 pairs have been given, 3 electrons have been given from the hydrogen. Now, in total, 8 electrons for carbon, 8 electrons for carbon, and for hydrogen, it requires only 1 electron to be shared. So, what happens is hydrogen has shared 1 electron, 1, 2, to complete its duplet, 1, 2. Here also 1 and 2. Similarly, here also and here also. So, this is how the methane is going to be, so this ethane is going to be formed. So the C2H6 means it is the ethane molecule. C2H6 is the ethane molecule. So here H, 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 H and H electrons are being shared with the carbon, and hydrogen is going to complete its duplet, whereas carbon is going to complete its octet. Okay, so this is how this ethane molecule is formed. Fine, I'll go on to the next structure, which is the electron dot structure of the water. Okay, so how this is made? O, H and H. Why O is in the center? Because this is the species having more electrons. So we'll write down the electronic configuration of O. What is the electronic configuration of O? It is 8, it is 2 and 6. Fine. Similarly, H has 1. So this requires how many electrons to complete its octet? It requires 6 plus 2, 8. 2 electrons are required. So we'll take up 2H. Okay. Now how this is being drawn? Let's see. Oxygen with 1, I'll just make a cross, 1, 2, 3, 4, 5 and 6. Or you could draw electrons anywhere, but it would be easier for you because you need to pair them up. So 6 electrons are there. How many 2 electrons are required, which will be donated from hydrogen? 1 and hydrogen here again. It becomes H2O. So this is going to be shared here. So now we'll count the electrons for this oxygen. The oxygen was having 6 electrons. Now 2 more electrons have been donated from these 2 H atoms, and it has become, now this has become the 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, similarly here also H has completed its duplet, which becomes 2 in its outermost shell now. Now here also it has participated with one of its electron from the H, which is donated from the carbon. So here carbon, this oxygen has donated. So this oxygen has donated one of its electron to hydrogen. Similarly, one of its electron is being donated to hydrogen this side. So it becomes 2 and 2 here. So what kind of bond it is forming? It is forming the single covalent bond in H2O. Okay, now how can you decide that what would become the central atom? This is very easy, that the atom which has to share most of its electron or more electrons will become the central atom. Here also this is having more electrons. Oxygen was having more electron as compared to this hydrogen. So this became the central atom here. So it completed its octet. 1, 2, 3, 4, 5, 6 and 7 and 8 electrons are there now. Similarly, this hydrogen also has completed its duplet. Now please ensure that the hydrogen has only one shell, that is the first shell, that is the K shell, and K shell has a maximum capacity to contain only 2 electrons. That is why this is forming only the duplet. It is not going to complete its octet. So remember that to complete its duplet it requires only 2 electrons. Okay, so this is how the electrons are being shared, and this is how the electron dot structures are being made. Now children, so these were some of the electron dot structure of some of the compounds which contains carbon, or molecules are being formed just because of covalent bonds. So this was showing you the single covalent bonds. Similarly, there would be some more chemicals, there would be some more molecules I'll form in the next video also, so that it would be a practice and you will be able to understand how is this electron dot structure is going to be made. But the main important point is that you need to understand how this sharing is being done and how to count the number of bonds. Here also only one single covalent bond is being shown. So today we have drawn the structure of the hydrogen sulfide, ethane, methane and water. Okay, so that's all for today's video children. I'll meet you all in the next video with the next topic to be discussed.